Welcome to officially the first video in this series. Okay, linear algebra with Python and Numpy. To be precise, we are looking at matrices and determinants. So the first question we're asking ourselves is, what is a matrix? So you could see a matrix as a rectangular arrangement of items. When we say rectangular arrangement of items, it means we are arranging things in rows and in columns in rectangular forms. Okay, it looks something like this. This is what you have here. This is what you call the first row. This is called the second row. This is called the third row. And then you have the first column, the second column, the third column. So that's what you call a matrix. It's a rectangular arrangement of items in rows and columns. Okay, now in this matrix I have here, this is what you call a 3 by 3 matrix, and that's actually called the shape, the order, or the dimension. Okay, so for a matrix, this is called the number of rows, the number of columns. We call that the shape, the order of the dimension, or the dimension. So this is said to be having 3 rows and 3 columns. For that reason, it's said to be a 3 by 3 matrix or a 3 times 3 matrix. Now, another way we can express it, we can say it is 3, 3, where the first represents the number of rows. So this part here is for the row, which is R, if I can do that, and this for the column, which is C. Okay, so that's what we have here. We also have the matrix can also be expressed, they can be seen as table generally. So when you have a table where we know that each row represents a record and each column represents a feature, especially when it comes to data science, okay, that's what you call a matrix. Okay, now a matrix can also be seen as a 2-dimensional tensor. We have what we call tensors. Tensors can be 1-dimensional, 2-dimensional, they can be n-dimensional. This is seen as 2-dimensional because we are looking at just 2 axes, the row axis and then a column axis. We have ones where we have more than 2 axes. In that kind of situation, we can basically talk about rows and columns in a way. I don't think we'll ever get to that in this course on matrices, because matrices are just 2-dimensional. We are not looking at 3-dimensional cases. Now, this matrix that I have here, that is having equal number of rows and equal number of columns, is called a square matrix. So once the number of rows and the number of columns are actually equal in the matrix, you call that matrix a square matrix. Okay. Another example we have is when you have a matrix like this. This one is having 4 rows and 5 columns. For the fact that it's having 4 rows and 5 columns, the shape or the order is going to be 4 by 5, okay, which you can write as 4, 5. And for that reason, if you're looking at the size is 4 times 5, which is going to give you 20. 20, that's the number of elements you have in this matrix. How many things can this matrix hold? The first one we have is 3 by 3, which can hold 9 elements. This 4 by 5, it can hold 20 elements. And this matrix we have is not a square matrix. Okay, it is not a square matrix because the number of rows is not equal to the number of columns. Now in this case, we also have 3 rows and 1 column. So this is also not a square matrix. So if you're looking at the shape or the order, you have 3 by 1, 3 times 1. The name we give, if talking about the size first, the size is 3 times 1, which is still going to give you 3, right? That's what we have. 3 times 1 is 3. But if you call this matrix, if you want to give it a name, we'll call it a column vector or a column matrix. Okay, because we have just 1 column, but we have too many rows. So whenever you have just 1 column, but as much rows as possible, that's called a column vector or a column matrix. We have another example. This is called a row vector or a row matrix, because here we have just 1 row. So in general, this is the concept we have. If I have just 1 row, 1 column, whenever you have just 1 column, and then you have n number of rows, so the number of rows can vary. So I have 1 column, 1 row rather. Sorry, this is a mistake. I think I need to wipe this. What do I use to wipe? Okay, that's a mistake. So let's say I have, cancel this is wrong. If I have n number of rows and I have just one column, that's what you call a column matrix, because you're having just one column. But in a case like this, where you have one row but n number of columns, this is called a row vector or a row matrix. So the shape is 1 by 5, which is 1 times 5. This will give us 5. We can also express it this way, especially when it comes to NumPy. This is how we are going to be expressing. When you have a row vector, is usually expressed just in terms of the number of elements it contains, which is going to be 5. So this is size, this is the shape or the order, and the rest of that. So this is called a row vector or a row matrix. Okay, so these are 3 different kinds of matrices we have, or 4 different kinds of matrices we have. The first one we said is a square matrix, number of rows equals number of columns. The second we said is a row vector, where we have just one row and then we have multiple columns. We say we have a column vector where we have just one column but multiple rows, and we also say we have a case where the number of rows is not equal to the number of columns. That one is not a square matrix. So the row vectors and column vectors are also not square matrices in general. Okay, so that's it guys for this video. Now in the next video we are going to be using the Numpy library in Python to demonstrate how we can create a row vector, a column vector, a square matrix, and also a non-square matrix, and also how to determine the shape of and the size of a matrix or an array in general. Okay, so that's it guys. Go ahead and like this video, subscribe to the channel, click on the bell button so that you get notified whenever I have new videos coming up. I'll see you guys in the next video. Bye bye.